Hey, science guys, how you doing? It's your Monday science video. This week we're going to get into a lesson on thermal energy called What is Thermal Energy? Another way to think of this is heat. We're going to talk a lot about heat. Now, last week in our video about energy in general, we talked about energy being things, moving around like light waves or sound waves. Heat energy or thermal energy has to do with movement as well. And last week I kind of mentioned how it's a little hard to understand. It is kind of hard to understand still this week. Um, just some of the sciencey definitions and what it really means to have thermal energy. Thermal, we might think of thermometers. You might think of like a thermos mug or like a Yeti that sort of keeps hot things hot or cool things cool without letting that heat escape. Um, so thermal energy we're going to get into today and talk about a few things. Some of the parts are, again, a little tough as far as like the concepts involved. Um, but the general idea is going to be more about how energy transfers, how heat energy transfers from one object to another, what the sources of heat energy are, and also ways we can use those forms of energy, which is an important thing as well for us to kind of think about uses for energy. If we can be using energy, usually that's a helpful things we can use and accomplish through technology and things like that, which we'll touch on as well. Okay, so our opening thing, we're going to actually look at a diagram in a second about cooking food over a fire. Now, we use heat energy to cook our food, whether it's on charcoal grills or campfires or ovens or toasters. Usually we use heat to help cook our food and make it nice and tasty and safe to eat and things like that once it's cooked up and tasting good. I want to talk all about that a little bit today. Okay, so if we go on to page 304 and 305, we get to this part called lively particles. This has a couple diagrams in it that are pretty key for us here today. And again, this is the page that's going to be for, it can be a little confusing because we haven't really thought of heat this way before, but this section is kind of important to talk about here as we talk about thermal energy, okay? So it says tiny particles that make up all matter are constantly moving, whether it's just the air around us flowing, like wind blowing, or in this case, like we might think of a hot mug of cocoa or even cold ice has particles. If we were able to look through a super duper microscope and see all those particles moving, we would see motion happening. There's energy in that, and that's what thermal energy is. So here it says thermal energy is the total amount of kinetic energy. You see this word kinetic. Remember that from last week? We talked about kinetic energy is motion, the energy of motion, things moving in the particles of a substance. So that is, again, kind of a tricky idea, but the idea is that the more heat something has, or the more thermal energy it has, the more it's moving. And one of the objects or one of the things in science that's really easy to help illustrate that is if we think of water. So we might have in this, like if we think of this being cocoa made with water or nice cold water for giving a dog a bath on a hot day. Today's a hot day. I actually just got back from my run. I thought that'd be a good day to do that. Today is Thursday, the week before, Thursday before you're watching this video, and it's finally a nice hot day. It was like 75 degrees out, sunny, lots of heat energy going around that we're getting from the sun, which we'll talk about in tomorrow's video about some sources of thermal energy. But anyway, the warmer air out there is actually moving faster than the cooler air, and that is the way we sense heat is by, or the way we sense thermal energy is by how hot or cold we feel things. So like we sense light energy, the light energy moving by our eyes are able to understand what that is and tell our brains the things we see. You're able to sense sound energy. Remember we talked about sound being energy, the voice, my voice coming through the computer into your ear is sound waves traveling, and our ears are able to sense that type of energy and make sense of it. The way we sense heat energy is by usually our touch, even just our skin on our face or our hands especially. When we feel hotter or cooler things, we're feeling changes or differences in thermal energy. So in this example, I like this diagram. It connects to what we see here. We see red meaning longer arrows, meaning they're moving around a lot faster, and that's this hot cocoa. So if we were able to, again, zoom in real close on the little teeny bits of water that make the hot cocoa mix, we would be able to see it moving around a lot. Again, the way we sense that, we don't see it moving fast, but we can feel the differences in temperature. Think about holding that nice, hot, warm cup of cocoa after maybe a cooler day out, and you can feel that heat. When you feel that heat, you're actually feeling the movement of the particles moving faster. That's the way our bodies sense it. Again, just like we sense light through our eyes and sound through our ears, we sense differences in heat through the way it feels on our hand, and that we're really feeling the difference of the motion of those particles. Again, this is where it gets a little bit weird and kind of far out there as far as understanding what heat or thermal energy really is and how we can sense it. But in the hot cocoa example, the particles are moving faster. There's more thermal energy, meaning they are hotter. And again, those particles are moving more quickly. They have more energy than the colder particles on a nice cool bath for a dog on a hot day. Or if like right now I have my drink of water, it's gotten some ice in it. When I drink that in, it feels cool on my tongue and cools my body down because it's not moving as fast. And so that feels nice. And so this cooler objects, again, we sense that less motion, that less energy by the coolness that we feel. So again, hotter things feel hot because we're actually sensing the movement of those particles compared to moving faster compared to moving slower in a cooler object that we might feel. Again, this is where it gets a little weird. Like what hot and cold is kind of basic, right? But that's really what it is and what we sense, okay? Now, the part that's a little easier to understand is if we get over here to temperature. Temperature, we know what that is. We use a thermometer to measure temperature, and we can assign an amount of degrees to that. It's the measure of the average kinetic energy of the particles in a substance. Basically, it tells us how hot something is or how cool something is, okay? So temperature does that for us. The faster particles move in a substance, the higher its temperature, like we were just talking about again with our hot cocoa here moving faster. It's got a higher temperature because the particles are moving faster. Again, we sense that as heat, hotter and colder with our fingers, with our touch, with our skin. We'll see an example of a person putting a nice cool towel on their face, and they sense that cooler temperature, meaning they sense the slower moving particles. And that's kind of what we get into on this page again, okay? Another part is they talk about things with more or less thermal energy. Basically, you could have two blocks of ice that are the same temperature, but the big block of ice would have more thermal energy because basically it just means there's more stuff. So it's a measure of how much movement there is in the total amount of substance that we have. So again, this is not a big emphasis here, but less thermal energy. These might be the same temperature, but there's more thermal energy here because we have a larger object, okay? So that's kind of, again, our opening part. Again, a little tricky, but just keep in mind this idea that things that are hotter have particles that are moving faster. So with water, when we freeze water, we slow down the particles so much that they basically don't really move much at all, and that's why it becomes a solid block of ice. When it melts, or when we have just a regular glass of water that we drink, it's sort of just a normal temperature, and it's moving at a rate or a speed of those particles to where they just kind of slide by one another, but they're still kind of stuck together, not so much as a hard solid block of ice, but flowing by one another in a liquid form. Then, if you were to boil water on a stove, eventually it starts to bubble, and as the particles move faster and faster, they get moving so fast that they kind of break away from one another, and the particles are able to go up into the atmosphere, up into the air, and that's the steam and the water vapor. Think about those stages of matter, right? As it goes from solid ice to liquid water, it starts moving more and more, and then when it moves fast enough and turns to gas, the water vapor, it evaporates up into the air because it's moving so much that it kind of gets away. All the particles kind of get away from one another and they don't clump together like in water or ice. So again, kind of far out there, kind of hard to understand at first, and definitely a hard thing for me to convey in a video, but we'll see a few things later on this week that might help you a little bit with it. But big thing here to remember is that temperature is a measure of heat. Things that are hotter have higher temperatures, have more thermal energy than things that are cooler and have less, okay? All right, let's go on to our next one. This is definitely a more important page and more important for understanding here. And this is about the way that things can move around, the way that thermal energy can transfer from one object to another. There's actually three ways this can happen. And this is kind of more of a bigger point of the work we're going to be getting into today. Okay. So on page 306 and 307, it says we're going to move it around, having to do with the movement of these particles as they go around from one object to another. Like, again, here we have a girl with a cold ice towel on her head to cool off after running around and playing soccer. So that is an example of what's called conduction, okay? So conduction is the transfer of energy between particles that are in contact. Contact, conduction, think about that. Things that are touching can transfer heat from one to the other as well, okay? So again, here we have an example of a girl with a cool towel on her head. Put it on there, you feel the heat transfer. In this case, you actually feel the heat leave your body and go over to the towel or the ice, and then that's where you feel cooler. So again, as the temperature becomes less, you feel the cool sensation, and in this case, that's what would be happening here. So again, things that are touching would be transfer energy through conduction. So if you are, say, cooking a pancake on a griddle that directly touches on there, and the heat goes from the griddle to the pancake and cooks it, makes it nice. You'll see a Bill Nye episode later this week that actually uses that as a great example of conduction, and these other ones as well. Okay. Another way that heat energy can transfer is from radiation. So radiation here, you may have heard that word radiation. Like our old heaters at GA were called radiators that we don't use anymore, but those things that are on the side by the windows, those are radiators that sort of radiate heat into the air. So radiation is the transfer of energy in waves without matter to carry it. So this is actually the way that we get heat from the sun. The sun gives us light energy, but it also gives us heat. Like I said, today I was out for my run and I just got back. It's pretty warm out today because it's more energy coming through radiation. The sun is not touching us, obviously. It's very far away, like we learned about in our space unit. But its energy is so powerful, it travels through space and gets to us and provides us with heat. And again, it's not directly touching us, but we can feel those waves of radiation. And then here we have another example. We'll look up here at the campfire in a second, but if you've ever stood by a campfire, the closer you get to it, you can feel that warmth. The further away you get, you don't feel as much, but you don't have to be like putting your hand down in the fire, obviously, to feel the heat. That would be conduction, which we definitely don't want to do. But in the case of having a nice campfire or roasting marshmallows, which we've done, my family's done that a couple times recently, which has been nice. We're using radiation to help us do that. We can kind of get our hands close to the fire enough to feel the heat, but we don't have to actually touch it. We can be a distance away, depending on how powerful, how strong or big the fire is, and that's radiation. So conduction is directly touching. Radiation is like traveling through matter, and we can feel that heat from a distance away. The last one is called convection. This has to do with the idea that heat rises, which you may have heard that idea before. Hot air rises. Convection usually happens with liquids and gases. So it says convection is the transfer of energy by currents in a liquid or gas. When liquids or gases are heated, the particles move farther apart. The fluid expands and becomes less dense. In the lava lamp, the heating element allows that heat to happen down here. Basically, when things grow hotter, they expand more and they're becoming more spread apart. And what happens is those hot things rise and the cooler things above it go down below it, kind of just shifting gears a little bit. And that's called convection. Convection currents happen in water. If you ever swam in a pond, you might notice the warmer water up at the top of the surface, and the further down you go, the cooler it gets because that colder kind of sinks below the warmer parts. And that's kind of the same idea there, okay? So that's our big ideas for today. That this page 306 and 307 is definitely where we want to focus our attention, and that's going to be the big ones there. So these three ways that heat transfers: conduction, direct touching; radiation, traveling through matter. We can sense the heat without being directly touching it. Or these convection currents: the hotter stuff rises and the cooler stuff goes down, and then it can kind of create that cycle. Okay, so let's go ahead and look up here. We have this analyze energy transfer thing just to kind of wrap up. I'm going to zoom in a little bit on it. So we're over here looking at this campfire example, which again, we kind of talked about in a couple different ways. Let's talk about where these three different things are happening. Okay, so first of all, these are always a little tricky, so it's good to talk about. The one area where we see the water, here we have hot water heating, and this would be rising, and this would be coming back down. Again, talking about liquids and gases, that's going to be our convection happening here. Okay, so we're going to call this convection for this one. Oh, it's bigger than I wanted. Convection. So this is convection happening. Okay. Our other two, let's go ahead and take a look at those now. Make this. There we go. That's good. Our other two. This example here is like pointing out into just space. So let's just imagine that we were a person having out here by the campfire, right? So again, we're not touching directly, but we're feeling the nice heat, and we're happy. While we feel that heat, again, we don't touch directly. So what kind is that? We've got conduction or radiation left. This is going to be radiation, okay, where we're not directly touching. Okay, so again, feeling the heat waves coming toward you without actually touching. Now the last one is kind of the pot. If the pot was directly touching the heat or from the fire, we put it down into the coals, that would be directly touching, and that's going to be our conduction. Okay, so on this one, we're going to talk about conduction taking place. Okay. All right. I am coming up to the end of my time here. So hope you enjoyed this. Hopefully this was good. Again, tomorrow we'll talk about some ways that we use heat and where heat comes from. But here's those three big things. Again, focus on 306 and 307. I hope you enjoyed following along with me today. Thanks for watching. I'll see you guys next time. Bye-bye.